Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazmi bin Anuar and my main sheet number is TE100140. So in this video, I'm going to explain about the circuit connection and I'm going to explain about the data collection for table 5.1, 5.2 and 5.3. So first of all, I'm going to explain about the data collection style of the table 5.1. So as you can see here, the speed of the motor is remain constant for the load from 0 until 0.8, and the value of the voltage for the line 1 until line 3 is almost constant, as you can see. And then for the current here is increased, which is the value from L1 and L3 is increased, for which the value of the current for the L1, L2 and L3 is slightly increased, as if the load increase, so the value of the current is also increased. And then for the value of power also increase if the load increase. And then lastly, for the power factor here, the value also increase. And but as we can see here, there is several value at the 0. When the load is 0.8, the value is 0. This is because when the load at 0.8, the motor it reached the motor limits, where the value for the power here, the value of the current and the value of the power factor here is uneven. So that is why the value is 0. I put here. Next is for the data collection style also for the table 5.2 and 5.3, which is for table 5.2, it is the data collection for the DC voltage and also for DC current. As you can see here, the value of the DC voltage is remain constant, which is 13 volt. And for DC current, the value is almost constant, which is 2.5 until 2.6. Next, which is the calculated horsepower. So in order to get the value here, the value of the power at the 3-phase here, we must divide with the value of 746, so we can get the value of the horsepower. So for example, in order to get the 0.15 here, so the value of 110.6 divided with 746, then we will get the value of 0.15 here. Next, I will explain about the circuit connection for the star connection. So as you can see here, the equipment that used for the circuit is the 3-phase power supply, the 3-phase measurement, the DC ammeter and the DC voltmeter. So this is for the analog, and then this is the digital, and then this is the motor drive. So for the connection, so from the 3-phase supply, which is the red phase, the yellow phase and the blue phase, and also the neutral phase, connected with the measurement at the voltage here, and then it connected here from voltage to current, and then from current it connected with the power, and then from the power factor here, the output here is connected with the red, yellow and blue, and from the incoming of the stator, which is the red, yellow, blue phase, is connected with the neutral phase here in the terminal of the common here. And then for the DC ammeter and the DC voltmeter, from the supply it connected with the terminal here at the DC voltage, and then here connected also with the DC current here. Next, for the common, connected here, and then from the common also connected with the digital DC voltmeter. So the connection here, as you can see, it is in parallel. And then after the connection is done here, supply from the here, the incoming here, connect with the carbon brush, which is the positive terminal. And then for common at the DC supply, it connected with the negative at the rotor. So that's all for the circuit connection of the star connection. Next is for the delta connection. The connection is the same for delta. As we can see from the start, it also the same for the delta, but the difference is the common terminal, the common connection is being removed. So as you can see here, there is no common, but the connection still the same. But at the motor drive, it's different. Where the supply here, the incoming 3-phase here, is connected with the each phase, which is the red, yellow, and blue. Red, yellow, and blue. From the incoming of the stator, from the red phase, it connect with the yellow terminal here, and then from the yellow terminal, it connected with the blue terminal at the stator, and lastly from the blue terminal it connected with the red phase in the stator. So that's all the connection for the delta. So I think that's all for me in explaining for the circuit connection. Next, I will pass to my friend Muhammad FAIZ bin MAZELAM to elaborate more. So thank you.
Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Muhammad FAIZ bin MAZELAM and my metric number is DE1044. So I'm the second member from group A8.2 from session 8 for Power Engineering Laboratory 3. So in this lab, I will continue with the lab presentation for the result or table for the delta connection. So as we can see, the speed of the motor are almost at 3000 RPM. As we increasing the load torque from 0 until 0.8 Nm, and the voltage was decreasing for the three lines that were red, yellow and blue line, and the current are increasing. For the power, for the three line for red, yellow and blue are increasing. For the power factor, for the red line is almost constant from 0.81 until 0.94, and then for the yellow line also increasing and constant and decreasing at 0.87. For the blue line keep increasing and then decrease at 0.74, but after the motor stop rotating, when we increasing the load or we set the load torque at 0.8, the RPM is 0, and then the voltage at the red line decreasing, but at the yellow line is increasing, blue line is decreasing, and the current for red line is increasing, yellow line is increased, and also for the blue line. For the power, for the red line is increasing, but for the yellow line is decreasing, also for the blue line. And then the power factor for red line is decreasing, same as the yellow and the blue line. So next, for the table for the DC voltage and DC current, as you can see, the DC voltage that supply was constant at 13 volt plus minus until 0.8, but when we set the load torque 0.8, the voltage is exceed at 16.66 volt, and for the current are constant almost 2.5, but after the motor is stop rotating, the current is 3.3. For the calculated horsepower, we use the formula P equals to horsepower times with 746. So when to get the horsepower, P is divided with 746, so that we get as the result shown at the table 5.6. Next, for the data connection at stator, as we know, when we doing the data connection, the neutral terminal is not be used. So to complete or to get the delta connection at the stator, same as the star connection, have 12 incoming and 12 outgoing for the poles, and then the difference is to get the data connection from the red outgoing will connect with the yellow incoming, and then from the yellow outgoing will connect to the blue incoming, and then lastly the outgoing from the blue line will connected with the red incoming. To that, all the connection will connect with common. So for the graph for star connection, as we can see, when we increase the load torque, the calculated HP, AC current at red line and AC current at yellow line keep increasing or directly proportional with the load torque. Also same for the blue line. When we increase the load torque, the current also increasing. And then for the DC current versus load torque, the DC current is almost constant at 2.5. So this next we go to the graph for data connection. Also same with the star connection. When we increasing the load torque, the calculated HP, AC currents for the red line and yellow line will keep increasing also, but the current is more higher than the current produced from the star connection. Also for the blue line, the current for AC is directly proportional with the load torque. And lastly, for the DC current versus load torque, when the load torque is increasing, the current is almost constant at 2.5 ampere, but after the motor was stalled at 0.8, current exceed more than 3 ampere. So I think that's all from us. Thank you.